Hey guys, it's IDW, and today I'm going to be covering something I bet you never thought I would ever cover. Just because my channel is typically, in terms of redstone, about some of the more advanced stuff like pipelining and addition and subtraction, but lo and behold, a piston door. I know what you're thinking. This is so lame, right? Well, actually, it has a concept in it that is extremely key in basically all sorts of digital redstone devices, and that is synchronization. So you might be wondering, what on earth is synchronization if you don't actually know what it is? And the answer is, it has to do with when stuff arrives. So here I have a bit of a demonstration set up. So basically, this is sort of like the floor of the piston door right here. So we want this is where our door is going to be. And we want this to basically move that piston to there. So what we would do is we would simply extend that and that first, just so that if we extended this first, then it would just push it out. And then we have to push that out. So now you think that's pretty simple, right? Well, to retract it, we can't just do that. That won't work because pistons can't pull piston extensions, and the piston will just remain there. We have to knock that out, and then we can pull it back. Now you might be thinking, okay, that's pretty easy to do, but it's actually probably the exact opposite of what you would think it is. Because if we make like a simple repeater-based like delay thing that just tells this thing to extend after a certain amount of time, well, the problem is that when we're retracting it, and I should probably just replace that with that. So let's say that it extends it like this, right? Well, the problem is that the signal is actually going to arrive here before it has time to retract from here. So yeah, that's the problem that you run into when you make something like this. And it's unavoidable. And if we flip this lever, sure enough, you can see it doesn't retract. So what I've done in this design right here is I've actually solved this problem. And yeah, in general, it's not the sort of thing that one would expect to happen inside of a computer, but it's one of the things that you probably wouldn't think of. So it has to actually do with where the blocks actually are. Because if you think about it, if we could just power this wire right here, the pistons could sort of potentially push the piston into it. So that's basically the idea behind this design. It's that, first of all, well, let's retract it. So first of all, this thing retracts right here, and then these two retract when it's retracted. Then when it extends, this wire doesn't power it up until the pistons have actually extended so that it pushes it forward. So that's the exact concept behind this design right here. And yeah, okay. So let's go on to just starting to build the basic thing. This time facing vertically though. So as you can see, this is basically all that we really need to do. First thing we should probably do, though, is we need to power both of these pistons with a bit of delayed time. So then, what we have after that is we just have a bit of redstone on top of here. So now we need to get that redstone to power this block in order to match the whole thing. To do that is really simple. So yeah, that's exactly how the double extension really works at its most basic level. And if we flip this, I didn't actually mean to flip it, but as you can see, it works like a charm. And if we put a block there, ta-da! Anyways, so the next one is a bit trickier. It's the exact same concept, though. We're just going to take two pistons, another piston right here, and then we're going to come up here wool on top of these guys, and I'm going to put the repeater on top of this guy. This way, the repeater doesn't actually power the piston, so it cannot extend until it's actually over this block, which has the redstone dust on it. So then the only thing left to do is to just take this guy right here and move it up to the top. So that is all very simple with slabs, and yeah. And why is it... Oh, no wonder. Anyways, so that's basically the front of the door. Now, actually, if you look in the back here, there's 2 pistons showing. And if you want to avoid doing that, you can actually just use a piston right here, power it like that. And yeah. At this point, though, it's pretty much just aesthetics. We've passed through all of the actual logic that there is in this, which is basically nothing. So, yeah. And that is our piston door complete. I also, on this one, actually have another feature that I've implemented, which is, as you can see, this block comes forward so that you can come up. And the way that you do that is really, really, really simple. Let's see. So let's just build the floor that we'd have. And let's just place the piston. So the piston goes right there. If I can place it properly, that would be very nice. And then all you need to do is just power it. And if I can place it on the right spot, it'll work. So yeah, and of course it got a 1-tick pulse, so yeah. And then it'll retract up and you have your piston door of awesomeness. So yeah, I hope you guys have enjoyed. This really was mostly for enjoyment purposes and entertainment, more than education and such. So yeah, and I'll see you guys next time, where we're going to be doing, well, after survival, the next survival, we're about to get into a huge and really advanced series, and I'm going to have a great time doing it. So yeah, see you guys then.